So for the last section of this chapter 6.6, we're going to talk about two different types of quadrilaterals. We'll talk about kites and trapezoids. And the reason why I said quadrilaterals and not parallelograms is because kites and trapezoids are not parallelograms. They do not have opposite sides that are indeed parallel. Trapezoids only have one pair, not both. So let's take a look at kites first. A kite is a quadrilateral and it has exactly two pairs of congruent consecutive sides. And on my diagram here, that would mean that consecutive right next to each other, I would have one pair of congruent consecutive sides, and then I would have another pair of congruent consecutive sides. So if you think about an actual kite that maybe you've flown in the past, the bottom two segments that are next to each other are the same exact measurement as the top two segments. Now, that is actually just part of the definition, and that's a property that we have. The other two properties that we worry about with kites would be, first off, the diagonals are perpendicular. So if I drew in a pair of diagonals for my kite, I know that they would indeed intersect to form right angles, so they're perpendicular. And the last property for kites that I have to worry about is that one pair of opposite angles are going to be congruent. So if I'm looking at it, I'm thinking, oh, okay, this pair of angles are going to be congruent, because the other two, the top one and the bottom one, the top one's a little bit bigger than the bottom angle, and those are not going to be congruent. So we're going to use these properties and the definition to help us figure out the next example. Alright, for this example, I tell you that ABCD is indeed a kite, and we're going to answer the following questions. The first question said, let's go ahead and find the sum of the interior angles of a quadrilateral. Now, you should know by now that no matter what quadrilateral you're dealing with, the sum of the interior angles will always be 360 degrees. That's always something good to know. Next, if we're taking a look at the next one, it says, what is the measure of angle D? Now, if I look at my diagram, here's angle D, and for the property of our kites, I know that one pair of opposite angles are going to be congruent, and it looks to be that angle B and angle D are congruent. So angle D is going to be 118 degrees. So let's go ahead and write that in by angle D. Now, to find the measure of angle C, remember we said that in a quadrilateral there's 360 degrees. So if I take 118 plus 118 plus 82 and I add all of those up and subtract it then from 360 degrees, I'll end up getting this angle degree measure at C to be 42, because all four angles have to add up to 360 degrees. Next, for segment AB. AB is this one right here. I know that there are two pairs of congruent consecutive sides in a kite. So the one that would be congruent to AB would be AD, and AD is 3.25. Lastly, CD and CB are going to be another pair of congruent consecutive sides, so that means CD should also be 6. So the next type of quadrilateral we're talking about is a trapezoid. And again, it is a quadrilateral and not a parallelogram, because in a trapezoid, I only have one pair of parallel sides. Unlike in a parallelogram, both pairs of opposite sides are parallel. The parallel sides that we're talking about are called bases. So if I look at my diagram, I know that AB is a base and CD is a base. The pair of parallel sides are called bases. The non-parallel sides in a trapezoid are called legs. So AD is a leg and BC is a leg. Now the angles at the end of each base are called base angles. So if I took them and I paired them up, I would say, oh, this would be one pair of base angles, C and D, and then A and B would be another pair of base angles. And they come in those pairs because later on it's going to make a difference when we talk about isosceles trapezoids. Speaking of later on is apparently now, and an isosceles trapezoid is a trapezoid that has congruent legs. So on my trapezoid here, I notice that the legs that we're dealing with, the non-parallel sides, are WZ and XY. So if I mark them, I know that WZ and XY are going to be congruent because they are my legs in my isosceles trapezoid. So that's one of the properties that you have to know for an isosceles trapezoid. The legs are congruent. As for the other two properties for an isosceles trapezoid, we do know in an isosceles trapezoid that both pairs of base angles in an isosceles trapezoid are going to be congruent, and we also know the diagonals of an isosceles trapezoid are going to be congruent. So, properties of trapezoids. We know that just the general trapezoid, one pair of sides, opposite sides, is going to be parallel, only one. But then, as soon as we talk about isosceles trapezoids, we have three additional properties. The legs are going to be congruent, my base angles are going to be congruent, and my diagonals are congruent. So all the other properties have to deal with congruencies. Alright, so take a look at this example. I notice that I am dealing with a trapezoid, and more specifically an isosceles trapezoid. It's a trapezoid because I've got these two marked as parallel, so I've got one pair of opposite sides that are parallel, and then my legs are congruent, so we have an isosceles trapezoid here. Now the next thing we have to think about is if I'm going to find out what x and y are for their measurements, I need to think about it. Okay, well, one of the properties of a trapezoid, isosceles trapezoid, was that base angles were congruent. Now, it's very important that you understand which pair of angles are considered to be base angles. In this case, I'm either working with x and 74 or with y and 74 as a pair of base angles. Now, the base angles will have to be made with the same base. So these are my bases, meaning my one pair of base angles would be x and 74. So I would know right away then, since base angles are congruent, that x has to be 74 degrees. As for the other angle of y, please notice that in a trapezoid, your bases are parallel. So if your bases are parallel, you're actually dealing with the same side C's, those consecutive interior angles. And we knew from before that consecutive interior angles, or same side C's, are supplementary. So y plus 74 would end up equaling 180, meaning y would be 106 degrees. The last thing we have to talk about with trapezoids would be considered the midsegment. Now, we've talked about midsegments for triangles in the past, and a midsegment for a trapezoid is along the same lines. If you're dealing with a trapezoid, which I will go ahead and draw out for you here as best as possible. Here's my trapezoid. If we're talking about the midsegment of the trapezoid, it is going to join the midpoints of the legs. So one of the legs, that's a midpoint, the other leg, that's a midpoint, and the midsegment is going to connect those. And since they are midpoints, I'm going to go ahead and mark them as being broken into congruent segments. So a midsegment, we're talking about this segment right here, that's the midsegment of my trapezoid, and it joins the midpoints of the legs. The reason why we talk about this is because a midsegment is actually, not only is it parallel to the bases, as of course seen in my awesome diagram, it also has a measurement that is 1/2 the sum of the two bases. So if I label this and I say, oh, this is my first base, and this is my second base, and this is my midsegment, I know my midsegment is 1/2 the sum of my two bases. And that's going to be important in the next two examples that we go over. So in this first example, they are indeed telling me that MN is a midsegment of my trapezoid. So we know that if it's a midsegment, I automatically have the midsegment is 1/2 the measurement of the sum of my two bases. So I'm going to go ahead and label it what it is that they've given to me. They've given me that RS is 2x plus 5, so we're going to go ahead and put that down. They tell me that TU is 5x plus 11, and they tell me that MN is 50. So setting it up, we said you're going to start off with your midsegment. So my midsegment in this case is 50. It is going to be equal to 1/2 the sum of my two bases. So I'm going to take my two bases and we're going to add them together. There we go. Now, this might be a little freaky at first because you've got that 1/2 there, but what I'm going to do is I'm going to get rid of it by multiplying both sides by 2. So when I multiply both sides by 2, 50 times 2 gives me 100, This 1/2 and this 2 are gone, so then all I have to do is put like terms together. 2x and 5x makes 7x. This 5 and this 11 makes 16. Now when I solve, I subtract the 16, so I get 84 equals 7x. Divide, we get x is 12. So all you had to do was go ahead and make sure that you knew how to set up the equation. In the next example, you're going to set it all up on your own. So we still have in this example MN being our mid-segment for this trapezoid. So I'm going to go ahead and mark them off. Why don't you go ahead and label your diagram. Make sure you've got RS is 30. That TU was your 3x minus 8. And that your MN is 5x. Using the same exact process how we did it last time in the previous example, why don't you go ahead and set it up. And then try to solve it on your own. Pause the video here so that I can have an opportunity to set it up too. And when you're all set and ready, you can start the video again and I'll have mine all worked out for you. Alright, so setup wise, start off with a median. Put your median down. It is equal to half the sum of your two bases, so 30 plus 3x minus 8. I multiplied both sides by 2 to get rid of the half, so I get 10x equals, and then all I did, once the half and the 2 were gone, I put my 3x down, and then 30 minus 8 was 22. I subtracted 3x from both sides, I get 7x equals 22, and then I divided by 7. So x is either equal to 22/7, or if you ended up doing a decimal, it'll probably be around 3.1. Make sure, if you have any questions, write them down, ask them in class, and we'll see you tomorrow.